Hey guys, welcome back. I have some notes here we're going to go over. I've posted these blank notes on Schoology, so you can fill out the blank notes if you want, or you can do this in your spiral. It's completely up to you. But today we're moving on to Chapter 8, and we're looking at 3 new skills. Number 1, solving triangles. Number 2, working on angle of elevation and depression. And number 3, working with bearing. So let's start with this first example here. We're going to solve a triangle. Up here at the top you can say, solving a triangle means to find all missing angles and sides. So example 1 wants us to solve triangle ABC, and it's telling us that A is 90 degrees. Remember back to Geo, whenever we use a capital letter in these types of problems, we're talking about an angle. So I'm going to call this angle A. Looks like it's 90 degrees. The B and the C kind of doesn't matter where I put it. You could flip-flop those if you want, but let's just put B up top and C down low. For side B, the lowercase letters will signify the sides. Side B is directly across from angle B. So whenever you have an angle and you want to find the side, go directly across. So here we have side B, and here we have side C. Lowercase is for those sides. Let's put the actual numbers there. Side B is 21. Side C, actually we don't know, but we know side A is 29. So to solve this triangle, we want to find missing sides, missing angles. The easiest thing to find first is the missing side. Because this is a right triangle, because one of the angles is 90, the easiest way to find the third side, given two sides, is Pythagorean theorem, which we've done a bunch of times in these last few chapters. So let's go ahead and fill that in. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. Be careful though here. The c we talk about when we use Pythagorean theorem is the hypotenuse. Don't get confused with the a's and the b's and c's in this triangle. So the setup for this is going to be 21 squared, that's one of the legs, plus another leg squared equals the hypotenuse squared, which is 29 squared. So instead of thinking about a's and b's and c's, you might want to think about leg squared plus leg squared equals hypotenuse squared. That's another way to think about the Pythagorean theorem. If you clean this up a little bit, the same way we've been doing the last few chapters, you'll get x squared equals 400. And then if you square root both sides, you'll get x equals plus or minus 20. But of course, in this chapter, we only want the positives. Now, one option you have instead of using x's to make things more flow nicer, you might want to go back and just use c for everything, since that is the side we're looking for. So there's one piece of the missing puzzle. We know that side C is 20. Okay. Now, to find the missing angles. It doesn't matter which angle we find first. Let's focus on C. I think that might be easier. If I focus on C, which is right here, the only way to find that angle is by using trig. Now, if you look what we have here, we have 21, which is the adjacent side, and we have 29, which is the hypotenuse. So if we think about our ratios with x and r and the hypotenuse and all that stuff, the ratio that has an adjacent side with a hypotenuse side is cosine. So what I want to do here is cosine of C equals 21 over 29. And that's the setup. Now there's other options. You could have gone to angle B and set up a sine equation. I would avoid angle A right now because it's just a little confusing. So now that I have cosine of C equals 21 over 29, just like we did in the chapter 7, we're going to cosine inverse both sides. So capital C equals the cosine inverse of 21 over 29. Type that into your calculator. One nice thing about this chapter is we're going to be in degrees almost all the time. So if you type that in your calculator, you should get an angle C of approximately 43.60 degrees. Okay, so that's next missing piece of our puzzle, 43.60 degrees. Now, to find the third angle, you could set up another trig equation, sine, cosine, or tangent, but the easiest way to find, if you know two of the angles, the easiest way to find the third is to subtract everything from 180. You know that all three angles have to add up to 180. So 180 minus the 90 minus the 43.6 will get you an angle of 46.4 degrees for angle B. And that is the solved triangle. All right? And that's what it means to solve a triangle. Now, for this first part of this chapter, we're focused on right triangles. When you see a right triangle, you should think trig, right? All the sines and cosines and tangents, and you should think Pythagorean theorem. Those are going to be the ways to solve triangles if you have a right triangle. Those only work for right triangles. Later on, we'll talk about non-right triangles, oblique triangles, and what to do with those. Okay, let's talk about angle of elevation and depression, okay? So, angle of elevation works like this. When you imagine your eyesight's right there. When you look straight ahead, which is kind of like this, right, straight out that way, and then you look up, that angle you make right there is your angle of elevation. That's it. Now the angle of depression, again, your eyesight's right at the top of this building. When you look straight ahead and when you look down, that's your angle of depression. That's it. Both of these start from looking straight ahead and then either looking up or looking down. The number one mistake students make with angle of depression is they call that angle right there the angle of depression. That is not the angle of depression. Angle of depression is looking straight ahead and then looking down. So watch out for that small mistake. Now, one thing I'm showing you here is kind of a nice little trick. The angle of elevation and the angle of depression will always be the same. If we look back at this first picture, okay, that you're down here on the ground looking up at the plane, but imagine someone's on the plane and maybe the pilot's looking down at you. When the pilot looks straight ahead and then they look down at you, there is their angle of depression. If you look at these two angles, this angle of depression and this angle of elevation, those will always be congruent because they are alternate interior angles. The lines of sight for the person on the ground and the person in the airplane are parallel. And then you remember from geo that alternate interior angles are congruent. That might help us in some problems making the pictures and making the triangles. Okay, let's try a problem with angle of elevation and depression. So here's the first thing. We have a 75-foot flagpole that casts a 43-foot shadow. We want to find the angle of elevation from the tip of the shadow to the sun. All right. I don't know why this little circle thing's there. I'm going to try to get rid of it. All right. Anyway. So this is very similar problems you did in geo. Let's practice it though. This problem is from a horizon view. So think about you're playing Angry Birds or some game like that. Here's the ground and you're looking at the horizon to see the situation. So the flagpole, let's call it that, tall, right, is 75 feet tall. Okay? And it's casting a shadow. Let's say the shadow ends there. Actually, that doesn't make sense. Let's say the shadow ends there. We know that this distance here is 43 feet from there to there. So the right triangle we want to make, if the sun's up here, right, casting down a shadow at that, or casting down light at that flagpole, causing the shadow to go here, there's your right triangle. Whenever something is coming off the ground, you can assume 90 degrees, unless it says clearly in the problem that the flagpole is not straight up and down, right? It might be tilted a little bit, and then that would not be a 90-degree angle, and you can't use trig, you can't use sine, cosine, tangent, and you can't use Pythagorean theorem. But again, that's coming up later. Today will be all right triangles. Okay, so now that we've got that, we want to find the angle of elevation from the tip of the shadow to the sun, meaning we're looking for this angle right there. That's the angle of elevation. So this becomes a problem just like the first one we did where you have to do sine or cosine. So take a second, pause the video if you need to, and see if you can't find a little equation, set up a little equation, and solve for the missing angle. Let's put a little X there, and we'll solve for it. All right, so let's see what you got. I had to run and get my calculator. I would have set this up. I would have called, because I have angle X is what I care about, I have the opposite side and the adjacent side there, right? I would have done tangent of X equals 75 over 43. That's the easiest thing to do. Now you could have gone and found this hypotenuse side using Pythagorean theorem, and then you could have done sine, you could have done cosine, but because I knew the opposite and the adjacent side, I went straight to tangent. If I tangent inverse both sides here, I get tangent inverse just like we did last chapter. So if I tangent inverse both sides, I get 75 over 43. type that into my calculator really fast. Make sure you're in degree mode. So second tangent inverse of 75 divided by 43 gives me an angle of 60.17 degrees, approximately. So I would tell you what to round to. Of course, on the assessments, my math lab will tell you what to round to. Sometime the nearest degree, sometimes something else. Okay, so that's an application of angle of elevation, angle of depression. Let's try another one here. This one is a depression. So we'll do this one together. Man climbs 213 meters up the side of the pyramid and finds that the angle of depression to his starting point is 52.6 degrees. That's where that little circle was. Sorry, should be a little degree sign there. How high off the ground is he? So here's where the guy starts, right? He climbs up the pyramid. So the side of this pyramid is what, the 213 meters. He climbs up, and now when he's up here at the tip top, he looks back down at where he started. So he starts off, he looks straight ahead, then he looks down like that, and that is the angle of depression. So be careful. It has nothing to do with angles inside the pyramid right there. The angle of depression is looking straight ahead and looking back down at where he came from. We want to know how high off the ground is he. So we have a few options here. His height is right here. When we do height, we can always assume 90 degrees. So if you look at the triangle that's inside right there, right, we don't know any angles yet. But what we do know is that this angle of depression here is the same as this angle of elevation. So this 52.6 that we know is up there is the same as this 52.6 that's down here. So that makes our triangle a lot easier to work with. We're trying to find his height off the ground, and look at the little triangle I'm using here. Again, I'm using sine and cosine and tangent because I'm looking for h. That's the opposite side. I have the hypotenuse side, so I'm going to use sine of 52.6 degrees equals my hypotenuse side over, I'm sorry, not my hypotenuse, my height, h, over my hypotenuse, which is 213. This problem's a little bit different because I don't have to do any sine inversing, right? Easiest way maybe is to think about that being a 1. Multiply both sides by 213. So you get 213 sine of 52.6 degrees equals h. And now you just go straight to the calculator. Type in this left side exactly how you see it. 213 times 52.6. And you should get 169. Let me fix that 6. 169.21. Now, not degrees here, meters. The original distance up the side was in meters, so his height is in meters. Okay? So that's a good application of our angle of elevation, angle of depression problems. All right. Last thing, bearing. So bearing's a little unique, but it's going to still create a lot of right triangles here. So you can read this quick introduction. It says, in navigation and surveying, the direction or bearing from a point O to a point P is the acute angle formed between the ray OP and the vertical line through O, also known as the north-south line. So, a lot of words there. Let's try this. Let's try to draw a little diagram here. So, here's the north-south line, right? If you think about a map, right? The north-south line goes up and down like that. Why can't I draw this? Now, here's the biggest thing to watch out for. Bearing is from the north and south line. This is the first, it kind of looks like our y-axis. This is the first time we've taken angles from this up and down line. Our reference angles from the last chapter, the angle of elevation, depression angles from just before, were all from the horizontal. This is the first time we've gone from the north and south line. Okay, so let's say we're at point O right here, right? And the direction from O to P, right there, is the acute angle formed from this, between this ray. So here's ray OP, and the angle in the north-south line. So this angle right here, that is the bearing. Bearing is an angle. Bearing is not a distance. It's an angle between the direction this thing is going, the direction something is going, and the north-south line. So let's try a few. Check these out. Now these are supposed to be 73. It's not supposed to be a rectangle. It's supposed to be degrees, degrees, no rectangle, and degrees. All right. So let's do south, 35 degrees east. So here's my north-south line. Southeast is somewhere in this direction, right? And 35 would be this angle right in there. So again, kind of like a reference angle, but instead of going from the horizontal left, east, west line, this time we're now going from the north-south line. Now if you need a quick reference, it's okay. This is north, this is south, this is east, this is west. No shame if you didn't remember that. Never eat soggy waffles. I'm sure you're learning that sometime in elementary school or something. Okay, let's try this next one. North, 80 degrees west. So north and west is this direction. Now if we want to make it to scale, 80 degrees is almost directly west. So it might look something like that, right? Maybe even more. But this is the angle here that is 80 degrees. This angle right here. So that is 80 degrees northwest. 45 degrees northeast. It's going to look something like this. That is northeast. This angle right there is the 45 degree angle. All right, so that is how you set up bearing angles. Let me show you an application really fast. This is the last thing we're going to do. So again, I don't know why these little rectangles are here there. That should be a degree mark. So a ship leaves port at noon and has a bearing of 27 degrees or south, 27 degrees west. If its speed is 20 knots, how many nautical miles south and how many nautical miles west will the ship have traveled by 6 p.m.? Okay, so let's set this up. Let's call this here, actually let me move that back to where I had it. Okay, so let's call this here the port. All right, we'll call it right here. Call that P for port. Okay, so the ship leaves going in a southwest direction. That's down here, right? And we know it's 27 degrees southwest, so that's 27 degrees. If he goes 20 knots, now knots is something I would give you a hint on. That's kind of like miles per hour in the ocean or in the air. So 20 knots, think about it as miles per hour. He leaves at noon. By 6 p.m., he stops. So say he stops down there. 20 knots for 6 hours, that's 120 knots. Again, knots are just like miles per hour, but in the ocean. So actually, it's not knots, sorry. 120 nautical miles, we'll call it, NM. All right, so that's where the boat is at 6 p.m. Now the question is, how many miles south and how many miles west has the ship traveled? So if you think about the ship's right here, from the port, this distance here is the miles south. This distance here is the miles west. So there's what creates our right triangle. So we're looking for this side here. Let's call this Y. We're looking for this side here. Let's call this X. And we're right back to the problems we've been doing all day. We have a right triangle, so we can use trig, sine, cosine, tangent, and we can use Pythagorean theorem if needed. Okay, so let's go ahead and find the y value first. Looking at the y right here, which is on this side, the only angle we know is 27. Now I know you can find this bottom left angle. You can do that if you want, but I'm just going to use 27. If I want to know the y side, and I know 120 nautical miles is the hypotenuse, I can use a cosine. So the cosine of 27 equals y over 120. Like we did in the last problem, think about this as over 1. Multiply both sides by 120. So you get 120. Cosine of 27 equals y. Don't have to cosine inverse. You just type that in as you see it. And you'll get 106.92 nautical miles south. All right. Now for the x portion, that is let me get the right color here. Oh, I guess I did that in green. Okay, let me color code that. I meant to do that in red, but you guys know My color's not that great, so we'll make that green. We'll make this bottom side red. All right, so now let's go find x. Again, we know angle 27, so for this I'm going to use a sine. Sine of 27 equals x over 120. Now, you could have also done Pythagorean theorem because you knew 2 out of the 3 sides of the right triangle. I prefer just setting up a sine or a cosine equation. So 120 sine of 27. So x equals approximately, I'm going to type this one into my calculator real fast, 120 sine of 27 should get us a distance of 54.48 nautical miles west of the port. Okay, so you can see with bearing and with elevation depression, a lot of times those problems set up a right triangle. You're using sine, cosines, and tangent equations today. You're going to use Pythagorean theorem a little bit. And that's about it. As always, with any questions, feel free to shoot me an email. But your assignment today is going to be the online homework called Homework 8.1. This is on My Math Lab. Hope you guys have a great day. And again, email me with any questions. I will let you know later in the week on Thursday what time my office hour will be that day. Okay.